So we're already getting a sense that the biggest changes, the most significant changes that are taking place are located here in the Dropbox header file, as far as we can see. There are new primitive classes that are added for the primitive circle, also deriving from primitive base. And since this is completely new, there's no need to use WinMerge to discuss this. We will discuss it in our next section, where we're going to open the project in Visual Studio and revisit the code from within the Visual Studio. Now here's the Dropbox itself, so what this Dropbox originally used to do is to maintain this vector of line primitives, and it would store individual objects of this type directly inside this vector. Now we're going to take advantage of polymorphic behavior of the draw function, which is a virtual function in primitive lines, primitive circles, primitive rectangles, and this is why we need to start storing pointers inside this vector. And the challenge here is that when we allocate new objects, when the user decides to create new line or new circle, they're allocated dynamically by the new operator. So we would like to be able to make sure that if and when these dynamically created objects are destroyed or need to be destroyed, we would like to manage them. And so unique pointer is a component in C++ standard library, which basically is an adapter for a specific type, which behaves just like a pointer, except when the unique pointer instance is going out of scope, when vector essentially deallocates all elements stored in the vector. Unique pointer will use the encapsulated pointer to delete the dynamic object. So unique pointer is a library component that we're using here to guarantee that things work exactly, for instance, just like in Java environment where you have garbage collection. Unique pointer allows to deallocate properly objects that were allocated dynamically. So we will see how we use it actually in the rest of the implementation here. But in general, unique pointers manage any dynamically allocated objects that are not shared by multiple objects. And therefore, it's safe to say that because only this location is responsible for existence and deletion of dynamically allocated objects, in other words, objects created at runtime, like lines and circles and rectangles, right? So only this object can be responsible for managing this dynamic resource. So the resource is not shared by multiple objects. Therefore, unique pointer destructor of this wrapper around pointers to our primitive base will call the delete operator, use the delete operator to delete the memory that is pointed by the pointer inside unique pointer. Once again, we will make a diagram of this behavior when we examine the actual use of it. Here I'd like to say that unique pointer requires a new header file, which is added here. Include memory. Okay, so memory header file includes the definition of this unique pointer adapter class. Okay, so back to the Dropbox. Now the Dropbox constructor now uses new integer, and so the Dropbox now remembers the type of the current type of the primitive that should be created. In the earlier version that was supporting only lines, every time the user attempted to click in a specific position and start dragging the mouse to create a new line, it would just go ahead and create new line. So this time the drawbox remembers which primitive has to be created, because it keeps track of the primitive selected by the radio button. And therefore it needs to be initialized, and it sets it to the line type initially. Okay, so everything else is really the same, and this is the new member function in our drawbox, which allows to change the type. So it just basically says, give me a new type and I will remember it. And of course it comes from this enumeration where we have lines and circles and rectangles so far. So the handle function, if you recall from previous series of labs where we discussed this dynamic environment where the user is using the mouse. So this is the handle member function for all events related to keyboard and mouse clicks. So right here, the change that is taking place before multiple primitives existed, only primitive line, we just created primitive line and added it directly to the vector of primitives, and it was all fine. It was very simple to use. But this time we say that we'd like to create an object of type unique pointer, and of course the pointer that it's encapsulating is the pointer to the base of the primitives. So we have this common base for all primitives, and we're now using a factory of primitives. Create primitive is a factory function, which is just a function that returns back a specific, dynamically allocates the object and returns back a pointer to it. And as soon as create primitive returns, we pass it to the constructor of unique pointer, specialized by this primitive base. And the create primitive itself actually is taking the primitive type and all the coordinates that are needed to construct a specific primitive. So let me show you immediately where this function is defined. And it's defined, of course, in the new file that sits under Fluid Project, drawbox.cpp. So there's an implementation file which now has this function create primitive, which basically takes the type of the primitive to create, uses the switch, and at the time of creation it says, okay, if the current selection by the user is line, we create the new line. And otherwise we create new primitive circle, otherwise we create rectangle. And so these are the new classes, and their construction is the same, and we simply return the pointer that is given to us by the new operator. So this function returns pointer to a brand new object. And so back to this comparison right here, create primitive will take the current primitive type that the drawbox remembers all the time now, and will construct this new unique pointer. So basically unique pointer now will be in charge of proper destruction of dynamically allocated primitive. Okay, and so because now we have a vector of primitives which stores these unique pointer objects, unique pointer behaves just like a pointer. So it has the member access dereference operator, the arrow operator. So the previous update was called directly for the line object. Now we have pointers, and we call update x2 and y2 whenever we need to call this function through the pointer dereference operator. So it's just a syntactical change that was necessary here to make sure that compiler properly resolves the pointer dereference operator, because the vector no longer stores objects. The vector now is storing unique pointer wrappers of the pointers. Alright, so this is it. So these are not big changes, but they are substantial, of course. Like we have some new things right here especially. And this is something that we have to discuss by looking directly at the code. So we'll just return back to the code window to complete our discussion with further examination of the code.